This is a fantastic question about how we can put the numbers 1 to 12 on a clock face and have it so adjacent pairs always add up to a triangle number. We're given the triangle numbers 1, 3, 6, 10, 15, 21. Just a little bit of information about them. They actually come from making triangles from dots. So we start with 1, and then we add like 2 to the bottom of it. So these add up to 3. And then we add 3 to the bottom of this one to get to 6. And then we add 4, and then 5, and then so on. So we then add 6, and then we would add 7 to get to 28. But we can ignore 28 because the highest number we could get from our adjacent numbers on the clock face would be 23 by doing 11 plus 12. Just one other piece of information, the formula for triangle numbers, the nth term is actually a half n times n plus 1. It's not too difficult to prove. You might want to look into it. Actually, you can get it by summing, because triangle numbers are also the sum of the first n whole numbers. So if you ever want to add the first 10 whole numbers, 1 to 10, then it's simply a half times 10 times 11, which is 5 times 11 or 55. Okay, on to the main problem. We're told that 12 is in the usual place. So I've drawn a diagram with the clock face and I put 12 at the top. And now I'm going to think about what I could pair with 12 to make a triangle number. So I'm already up to 12, so I can either get 15 by using 3 or 21 by using 9. Now it's not going to matter which way around I put it. I'm just going to get like a mirrored answer. So I might as well just put 3 here and 9 here. And I can continue round. So with 9, I can either get to 10, or I can get to 15, or I could get to 21 by using 12. So actually, I've got 3 choices here. I'm going to leave that one for the moment. With 3, I can't get 6 because I'd have to use 3 again. Can't do that. So I could get 10 using 7, or I could get 15 using 12, which I've already got. So this must be 7. And just carry on like this. So I could use 3 or 8, and that's it. So that one's going to have to be 8. I could use 2 or 7. So that one's going to have to be 2. I could use 1 or 4 or 8. So I actually have a choice now. I can either put 1 or 4 down here, and I can either put 1 or 6 down here. So I'm just going to pick one of them, and I'm probably either going to get some sort of mistake, like it's not going to add to a triangle number, or it's all going to work out. So let's go with 1 down here, and maybe in a minute I'll have to take a look at what if I'd chosen 4. Okay, so I'll just circle that one. Okay, let's proceed. So if I put 1 down, then I could either use 2, which I've already used, or 5, or 9. But 9's already been used, so this will have to be 5. Okay, good. And then if I've got 5, then I can either use 1, I can't use 5, 10, so 10. Then 5 and 11. 4 and 10 seem to be working. 2, 6, 11. I've already used 2, I've already used 11, but I've not used 6. Actually, that was the remaining one I hadn't used. And then 9 plus 6 is 15. So this seems to check out, and the answer is probably going to be 5. Let's just check the other method didn't work. I mean, you can guess in this competition it's not going to. There's going to be one answer, but it's always good to just be really, basically cover all bases. So the alternative to picking 1 here was to pick 4 because we'd already picked 8. Okay, so let's proceed from here. So with 4, we can either pick 2 or 6 or 11. Okay, that's a bit frustrating because I've actually got 3 choices again. But if I picked 11 here, then 11 can only go with 4 or 10. So this would have to be 10. And then 10 only goes with 5 or 11. So this would have to be 5. And then 5 only goes with 1 and 10. So this would have to be 1. And 1 only goes with 2, 5, or 9. But we've already used all of those. So this fails basically. If instead, with the 4, we went with, I think it's 6, because I've already used the 2. Right, will this work? Well, with 6, oh, I didn't ever write that one down, but with 6, we'd either go with 4 or 9, and I've already used both of those. So again, this is going to fail. So the only way we can make it work is with this arrangement. You can obviously rotate it around. You can reflect it or whatever, but it has to be those numbers next to each other. And in this case, with 12 at the top, 12 has to be opposite 5. All right, brilliant.